So chapter 1 is just an introductory chapter that will help us set up a base of what analytics is and how we might use it. This is the book that we will be using this semester. And the first chapter is an overview of business intelligence, analytics, and data science. So what is analytics? Well, if you Google it, you'll get the definition: the systematic computational analysis of data or statistics. Well, what does that really mean? I would define analytics as the use of available data to make better decisions through the use of statistics or other algorithms. I don't know if that's any simpler, but. So let's look at some examples of how analytics can be used. There are many sources of data. One such source is consumer market surveys. Generally, this is free information that we can use to make decisions, especially in advertising and marketing. One instance is how NBC's data science division initiates targeted advertising. So NBC collects information from viewer habits and analyzes how to place a targeted ad. This usually involves advanced machine learning algorithms like random forests or neural networks. And these are the algorithms that, if you learn, will help you make a lot of money, particularly as a data scientist or an analyst. Kind of will set you above other competition of people that only know how to use Excel. A little bit more about what NBC, the data they collect. They can get a hold of credit card records, so they know how you spend all your money. They get records from like the DMV, so they know when you last bought a car, how long you've had that car, and what kind of car it is, right? So then if they were going to do directed advertising at you for buying a new car, they know the history of how often you buy new cars and what kind or price range, so that they can set up the right ad. If you generally only buy lower end cars, maybe they will send ads from Hyundai. But if you make lots of money and you generally buy high end German cars, then you might get a Mercedes commercial. And that works out better for everyone, because somebody doesn't generally buy Hyundais, then showing them an ad for that is a waste of NBC's time, your time, and Hyundai's time. So there are positive and negative effects to targeted advertising, but business analytics and data science are really helping that field move along. So here we want to look at the evolution of the field of analytics. The earliest form started in the late 60s, early 70s, with the evolution of decision support systems. So we started with this flat file reporting. So we had, on paper spreadsheets, let's say, before that. And we would only do simple statistics like mean and median or the range of a particular data. When we introduced the computers, or made them slightly more available than they were before, we increased the ability to make computer-supported decisions. And as the amount of data increased, the data started to be placed into databases, which made the data harder to easily comprehend. So a decision support system utilizes a software system to make analyzing the data easier. Finally, a user interface is necessary for the end user to use to make those decisions. As a quick review, the three components necessary of a decision support system are a database to store all the data, a software system so that we can analyze that data, and then a user interface for the decision maker to actually get reports out or analyze the data and make their decision. Anyways, moving along the timeline, we make advances in databases with the relational database, which you will learn more about in other DSIM classes. Over time, we found better ways to store and access the data. We needed to make decisions, such as using a data warehouse. In the past 20 years, we have greatly advanced what we can analyze or found new services in how we analyze the data, such as with text mining, which you will do in a few weeks. And we have accumulated so much data at this point, both structured and unstructured, that we had to look at new ways to analyze the data. As you can see, all the time you spend on social media has helped a lot of companies make more money by picking up trends in your behavior. Hence the end, we have social network or social media analytics. The development of business intelligence has created an array of new positions for analysts. Business intelligence can mean different things to different people, but a good working definition would be an interactive way for managers to access and manipulate data. Some common softwares for this are Microsoft Power BI or Microsoft SQL Server Analysis Services. And in the world of big data and unstructured data, you have Apache Hive, which is part of Hadoop and big data, which we'll talk about later in the semester. So a business intelligence system, well, later in the course you will work on some certificates for Hadoop, which includes Apache Hive. So a business intelligence system has four major parts: a data warehouse, which really is just a database used for reporting and data analysis. Second thing you need is a collection of tools to manipulate and analyze that data. Third is a way to monitor business process performance. So when we're doing the reporting, we need to monitor how our analysis is going, and as well as how does it attach to our business objectives. Finally, we need a user interface such as a dashboard, which you should have built in the prerequisite to this course. As an example, back when I worked at UVA Health System in the revenue cycle department, I developed dashboards in exactly this process. We had a data warehouse that held all the data. And the interesting thing was they actually had two data warehouses that were mirrors of each other. So they'd take one down as they were uploading all the new records, and then you'd report off of the other data warehouse. And then when the other one was up to date, they'd take the other one down and they would cycle back and forth. But just kind of a nuance of what a data warehouse does. We use Microsoft SQL Server. So I had to use SQL to query and pull the data I needed. I would then usually bring that down into Excel to perform the analysis and set up reports. And then I would develop a report or a dashboard that someone like the Vice President of Finance would use. So very important to current job market to be able to build dashboards and use Excel. But as we're moving forward, the more advanced softwares we're going to go over in the semester is really going to be what helps you get a job, especially if you're interested in data science. So this figure gives a high-level view of how the architecture of a business intelligence system works and how the different parts relate to each other. We start on the left side, and we have some source of data. So possibly insurance claim data, for the example of the revenue cycle at a hospital. The technical staff takes these streams of data and organizes the data into the data warehouse. So we have data coming in from the left. The technical staff here is going to build a data warehouse and then organize that data into the data warehouse. This is a pretty good job if you are more introverted and you don't want to have to deal with a lot of people or presenting data. You're just building a a data warehouse, you would take a job as like a data architect, pays a lot of money, 6 figures. Takes a little while to get there. You're not going to get that immediately out of school, but it's a good job. And you organize that data into the data warehouse. So the next phase is the business analytics phase. So here is where a data analyst or database analyst will query that data warehouse, manipulate the data, and produce results to share with the managers and executives. Also build the interactive dashboards at this point. So there is a small block here, down here, that connects in if you for intelligent systems. So this is where if you learned a scripting language like Visual Basic for Applications or VBA or Python, you can automate a lot of these queries and reporting. But you can make your job as an analyst a lot easier. When I worked in Revenue Cycle, I found that a lot of the stuff I was doing was repetitive. So I wrote a lot of scripts that would go query the information, pull it down into Excel for me, do all the analysis, and send it into a report. And I had to do absolutely nothing. You can schedule it on your computer, and it runs it all, and then it creates the report. The final block is for managers and executives. Over here, this is where they use the reports and dashboards to do business process management and develop strategies to drive the business forward, ultimately trying to make more money. Okay, so we can break business analytics down into 3 categories, all of which we will cover over the course of this semester. The 3 kinds of analytics are descriptive, predictive, and prescriptive. Descriptive analytics is the use of summary statistics like mean, median, mode, variance, etc. And the goal of this is to determine what has happened. This is most useful for well-defined and is utilized in basic business reporting. The next kind of analytics is predictive analytics. The goal of predictive analytics is to predict what will happen in the future. The techniques used here include forecasting and data mining. We will also talk about that this semester. Final kind of analytics is prescriptive analytics. And an easy way to remember this one is it's like how a doctor prescribes medicine. The doctor is telling you what you should do in order to get better. The same idea is with analytics. We want to tell you what you should do in order to solve a business problem or to make more money. Typical algorithms in prescriptive analytics are simulation and optimization. In descriptive analytics, you can use Excel and do slicers and dicers to analyze the data and other tools to do exploratory data analysis. Some typical outputs include bar charts, word clouds, box plots. You can do hypothesis testing and other basic descriptive statistics like mean and median. This is stuff that you should have done in previous classes for your dashboard. Now, on the other hand, predictive models use data mining and machine learning algorithms to train a model to predict some future outcome. Some algorithms that we will go over in this class are simple linear regression, random forests, and neural networks. Prescriptive analytics has a different approach. This is where you would build different kinds of models like simulation for Monte Carlo simulation, discrete event simulation, or agent-based modeling simulation. However, optimization models would include things like linear programming or integer programming, among others. Probably won't focus as much on this, depends. Big data analytics. So the last point is on big data, which we will discuss in more detail later in the semester. Right now, we can define big data as it is characterized by high volume, variety, and velocity. So the 3 V's, you'll hear that a lot. So we were receiving a lot of very different data at a very fast rate. So to do this analysis on big data, you generally need like parallel computing capabilities and special software like Hadoop, which you will get a certificate later in the semester.